of conics, on ellipse and the parabola, even the circles. All right. Okay, so today we're going to be looking at hyperbola. So I welcome you to this class, and in this video we're going to be breaking down hyperbola in a simple and easy way to understand. You're going to be learning definition of hyperbola. You're going to be learning the equations, the graph, the asymptotes, the eccentricity, the vertices, the foci, and how to solve hyperbola problems step by step. So please do not jump this video, watch to the end. And I believe you've enjoyed our previous video, so do well to like, comment, and share. So first off, what is hyperbola? Now, hyperbola is a set of all points in a plane such that the difference of the distances from two fixed points, called the foci, is constant. Now, below this definition, you're seeing the graph of a hyperbola. So with this graph, I'm going to be explaining a whole lot. With this graph, I'm going to be explaining the vertex or vertex. I'm going to be explaining the foci. I'm going to be explaining the asymptotes, the eccentricity, and so on and so forth. From this definition, we're going to be setting the standard equations. We're not going to be deriving it due to time. All right? Beautiful. Now, this hyperbola, I believe you've watched the video on ellipse and parabola. You would see that it is just the opposite of what? Of the ellipse, right? Good. Why is it the opposite? In ellipse, we said it's a set of all points such that in ellipse, it is the sum of the distances from two fixed points. While in hyperbola, we have what? Difference of the what? Distances. Okay? Now, why do we have difference here and sum in ellipse? So let's quickly do that comparison while we move to with the ellipse. We explained all other conics, right? Now we said this is a conic connected at the pebble. It is only hyperbola that the plane cuts across the what? This pebble. For an ellipse, it is this way. For a circle, it is this way straight. For a parabola, it is at this point or at any point on the on the conic. It is only hyperbola that moves from one end to the other opposite end rather. So now, as it is moving from one end to the other opposite end, it cuts at this pebble at the center, hereby forming two opposite curves that can never meet. This is going this way, this is going this way. By the time you open it, are we together now? Beautiful. Now, for an ellipse, the difference between an ellipse and a circle is the fact that the plane cutting this didn't cut it at the center. That's all. If not, it moves round a particular axis, either the x or the y axis, right? So now for this ellipse, it's just like two curves coming together. Look at it. Look at this curve. Look at this curve. Do you get it? So an ellipse is just like two curves coming together to form a shape. All right, good. But for a hyperbola, now why I'm comparing with ellipse is that all the things you're going to be doing in hyperbola, it will just be like in your English language when you have words and opposites. All right, so in ellipse, when we say stand, in hyperbola, we say sit. So I'm just trying to tell you why. Now, in hyperbola, we have two curves that will never ever meet in their life. This one is facing this way. This other curve is facing that way. Are you seeing why we take the difference this place called? Now, this is the point where the curve, you know that hyperbola is actually into two types. Do you know that? We have the horizontal. You have the horizontal hyperbola, And then we have the vertical hyperbola. Beautiful. So now in this class, what we're going to be using is this horizontal hyperbola. So now what makes this hyperbola horizontal is the fact that the curve is on the x-axis and not on the y-axis. All right, good. So this is a horizontal hyperbola. So now since it's a horizontal hyperbola, it means that at this point where this curve cuts the x-axis, we'll have our vertex. And since this is on the x-axis, we will have what? Our y is 0 at this point, right? Beautiful. So now coming to this side, we're going to have two vertices. So this is V1. This is going to be what? V2. We have minus a comma 0. Now, if you take the measurement from the center to this vertex, it will be equal to from this same center to this other what? Vertex. Beautiful. Now relax, I'm going to explain everything on this graph. Now, the next thing you need to know is what we call the what? The focus. Now, this focus is a fixed point that must be inside the hyperbola. All right. So now where is inside? Now, this is a curve. This is a curve. You're seeing the curve. All right. So anything on this line is inside this curve, while anything behind is outside the curve. The same thing with this other one. So now this is a fixed point that defines this what? Hyperbola. So we have our f on this side to be what? C comma 0. And then on this other end, we'll have our focus f2 to be minus a comma 0. Remember, this is a horizontal hyperbola. Sorry, this should be minus c, not minus a. Now, if this were to be a vertical hyperbola, our vertices or vertex would have been 0 comma a, while our focus would have been 0 comma c and then 0 comma minus c. All right, that's if our parabola were to be something like this, where we'll have this going this way, this going this way. Do you see that now? Beautiful. So in that case, remember we said focal has to be inside the parabola. So our focal would have been here and it would have been 0 comma a. And then here it would have been what? 0 comma minus a. The x coordinate first before the y. Are we together now? Beautiful. So now, what else do we need to know about this? I've told you about the center, I've told you about the vertex, I've told you about the what? The foci. Now, the next thing you need to note, you need to note let's write down these things I've told you. The center, so that we'll know the one we've talked about. So we have it to be 0 comma 0. Then we have the vertex. Since it is on the x-axis, we have it to be plus or minus a comma 0 for the x-axis. But then if it's on the y-axis, I said it will be 0 comma plus or minus what? A. So take note, the way you write it determines if you will be correct. In an exam, don't just say I've gotten A. It's a coordinate, so you have to state it properly. That's why you need to know what happens if the vertex is on the x or on the y axis. So the next thing is your foci, and that is plus or minus c comma 0 if it's on the x-axis, and then we have it to be 0 plus or minus c if it is what? On the y-axis. Okay, so now before we proceed, we're going to be using the graph to interpret everything. Now, the next question, you see this line. At here, we have x to be equal to a. That's your equation of directrix. And then here we have x to be what? Equal to what? Minus a. So you have x to be equal to plus or minus a as your equation of directrix, right? Beautiful. Now, the next thing you need to note, which is very important, how do we find this foci or focus? That is one. Two, this asymptotes, what is it? What is it all about? If you look at this, you discover that we've been talking about the focus and the vertex, and it is on the x-axis. So what happens on the y-axis? Now, what is this line? What is this line doing here? These two lines that meet themselves at this center, this is what we call the asymptote. So let's call this, let me write it here. Okay, beautiful. So now these two intersection, what is an asymptote? An asymptote of a hyperbola are two straight lines intersecting, such that intersecting lines that passes through the center of the hyperbola. You see it? Two intersecting lines that passes through what? The center. Remember we said that this is the center of the hyperbola. So if I join this here, you know that this is a continuous line. I hope you know. Yes. And then maybe if I also join it here, I've gotten my A, right? Okay. This becomes my B. Y here is my what? Minus B. Right? Good. So now look at this. Look at this. This is my B. This is my A. Let me draw it out. On the y-axis, I have my B. And then on the x-axis, I have my A. All right? So this is my... So now this my focus is the distance from this A to my B. So to find my focus, I have C squared to be equal to A squared plus B squared. Now, have you seen the difference between focus in a hyperbola and focus in an ellipse? For focus in an ellipse, we take difference of squares of the what? Of the vertices. Difference of squares of the vertices gives us the focus. This is for an ellipse. Asymptote is going to be, that is this line. Since this hyperbola is on the x-axis, I will have my y to be equal to b over ax. All right? If the hyperbola were to be on the x-axis, it would have been x is equal to what? B over ay. Are we together? Beautiful. Now, if I pick any point on any side of this hyperbola, let me pick a point here, P. You know, this hyperbola is on the coordinates. That's the x and y coordinates. The x and y plane. So we have this point. This point is here. If I measure from here to this, and then I measure from here to this other focus on this other side, what happens? Let's look at that definition. Now we said hyperbola is a set of all points in a plane such that the difference of the distances from two fixed points. So that means if I measure from P to F2 or from P to what? F1, it's going to be the same. It's a constant. So at any point I pick, you know, P can be any point. Before we look at the standard equation, is the eccentricity. So for any conic, I've said its eccentricity is C focus over what? Over the vertex. All right, so you can have C over A or minus C over minus A. And then eccentricity of a hyperbola, we said it is greater than what? 1. So please, if you haven't seen the first video where I explained ellipse, when I tried to balance the eccentricity of an ellipse, a parabola, and a hyperbola. I remember sharing in that video that the reason why the eccentricity of a parabola is 1. So please go and watch that video. All right. So the eccentricity of a hyperbola, we said, is greater than 1. So what is the standard equation? So the standard equation of a hyperbola, if it's on the x-axis, we have it to be x squared over a squared minus, just like that of an ellipse is plus, that of a hyperbola is minus. So these are things you need to what? Take note of. Be very careful. In an exam, if you are given a question on equation of a hyperbola, please be careful. The difference between this standard equation of a hyperbola and a parabola is just the sign. For a hyperbola, it is difference. While for an ellipse, it is what? Addition. So what will make you to always remember is this thing I've said earlier. Just always note, if you hear ellipse, just know that I have two curves and the two curves met each other. So they come together, plus. If you hear a hyperbola, what comes to your mind? I have two curves. The two curves can never in their life, one is facing Cotonou, the other one is facing Cameroon. They can never turn and see each other. So it is minus. Are you getting me now? Beautiful. Now, this first equation is when the hyperbola is on the x-axis. So what happens when it is on the y-axis? We'll have x squared over b squared minus y squared over a squared is equal to 1. So I believe we have seen what to expect. If you know how to find your vertex, how to find your foci, your eccentricity, the standard equation of a hyperbola, the asymptotes of a hyperbola, I think you're good to go. So let's quickly pick a question and then let's see what happens. The vertices and foci of that equation. So what do? The first thing to do is to write down the standard equation, which is x squared over a squared minus y squared over b squared. Now, before I proceed, I want to say something. You might say that it will be known to you that this is a hyperbola or an ellipse. But let me say something. You see, this example is because the equation has been given to you in its standard form. Note that an equation can be given to you in its general form, where you have to break it down to the what? To the standard form by dividing through by the constant, just like we did in ellipse. I hope you know that. Beautiful. So in that case, what happens? You see, that's why you need to note which one is which. All right, perfect. So let's proceed. Now, having written down this equation, compare it with what we have in the question. X squared over 16. That means that our b is equal to what? Plus or minus 9. Okay, so now we are asked to find the vertices. So I think that's a settled case. So since our a squared, a will always be greater than b, right? Good. So since our a is under the x squared, it means that this hyperbola is on the x-axis, which is like the example we used to explain everything about hyperbola. So that means that our vertex is going to be what? 4, 0, or I can say plus or minus 4, 0. You have 25. So taking square root of both sides, you have your c to be equal to plus or minus 5, 0, since it is on the x-axis. So I want to believe that with this you've understood hyperbola. So now what about tangent? So if the standard equation is x squared over a squared plus y squared over b squared is equal to 1, it means that tangent, that is the point at x1 comma y1, there's a straight line that touches the curve at one point. All right, so now our point has moved from x comma y to x1 comma y1, so we'll have x1 over a squared, simple as that, plus y1 over b squared is equal to 1. So you use this form to get to your what? Equation of tangent. You know, equation of tangent is just equation of a straight line. So you're going to multiply through by the LCM, a squared b squared, to have equation in terms of x and y. Simple. So now, if you now want to find equation of normal, I always think the easiest way to do that is, because in most questions, it is always find equation of tangent and then find equation of normal. All right, I keep saying it that, okay, assuming this is a curve, and then there's a straight line this is a curve. Then there's a straight line that touches this curve at this point. You know that there's a coordinate here. You have the x and then you have the y-axis, right? Good. Now, this is the tangent. Now, if this is a tangent, at this point, this is a normal. Do you see that? So that is why we always say that the slope of tangent is perpendicular to the slope of normal. All right. So if you find the equation of tangent, slope of tangent, I've explained this in the video ellipse, that's why you have to watch it, times this is equal to minus 1. So to find the slope of normal, divide the slope of tangent, divide minus 1 by the slope of tangent. And when you do that, use your 1-point form, gradient in 1-point form, that is your y minus y1, to be equal to the slope of normal times x minus x1. For any kind of conic, you are good to go. To avoid, there are a whole lot of things to get used to, a whole lot of formulas to note and all that. Now, in this example, what if we are asked to find the asymptotes? Remember, it is y is equal to what? Y is equal to plus or minus b over, you see that is an equation. So you've gotten our b to be plus or minus 3, plus or minus 3 over what? Over 4x. Okay? And that is it, as simple as A, B, C, D. So now, if this video has helped you to understand hyperbola, please don't forget to like, share, and subscribe to Barrister of Maths for more simplified maths lessons. Bye!